Buddy, so welcome to a new question. So what we are trying to solve over here is the question in Leetcode 1235, which is called maximum profit in job scheduling. So what does this question say? So we have n jobs where every job is scheduled to be done from start time I to end time I, and we need to and it that obtains a profit of profit I. So we have three arrays, which is basically the start time, end time, and the profit. We've got three arrays, and here we need to return the maximum profit that you can take such that there are no two jobs in the subset which are overlapping, or that is having the overlapping time range. And in this case, so for example, there is a certain time where a job ends, you can start the next job at the same time. So it's not that we have to start at a maybe a second after that job, maybe x plus 1. So we can start a new job at the same x time. So this is something to note, and it is something very crucial for this question to be solved. So now what happens is, so for example, can we solve this greedily? Because the moment I see this question, I feel there's something to maximize, and then if there is something to maximize specifically profit, it looks like that we can solve this greedily. But after certain thought, what we have realized is that it cannot be solved greedily, because we are not aiming here to maximize the number of non-overlapping ranges. We are not trying to maximize that. So because if we wanted to maximize that, all we had to do is sort the whole thing with the help of end time. So we get the maximum number of jobs that are ending first, and then we can just sum the profit of those jobs. But we can't do that over here because it's overlapping, and in this overlapping case we have to make a choice whether to pick that job or whether to skip that job, right? So when that concept comes where we have to pick, it's either this or that. So then the concept of dynamic programming comes. So now we will start with the brute force solution, and then we'll try to optimize that, and then we will finally reach to the optimal solution with a slight modification in the brute force solution only. So as I said in the question, we've got three parameters to start with, which is the start time, the end time, and the profit. So all these three things are interrelated. So can I basically schedule them, or basically encapsulate them in a certain data structure? I can use that. What I can do is, or if not, I can simply declare a global variable. Indentation should be right. Vector of vector int, and I'll just name it as jobs. The reason why I am declaring it globally, I'll tell that shortly. So all I need to do is, and then I'll just declare a variable as well, int n, which will be the size. So over here, n will be the size of the whole array, and since all these arrays are related to each other, so all these three arrays will have the same size. So I can just take any of those array and I can get the size. So now I have the n. So now all I have to do is, for int I equal to 0, I less than the n, I plus plus, I'm basically merging them or encapsulating all these three parameters into one, which is the vectors of vectors jobs. That is what I'm doing right now. So I'll write that comment over here. So I am encapsulating the three params into one. That is what I'm doing over here. So I'm inserting here, so jobs dot push back, and since it's an array, I need to use the curly braces, and it's over here start time I and end time I, and then we've got the profit of I. So that is done. So now what can I do? I basically, as I just discussed in the question, we need to basically go through each combination of the jobs, whether I need to pick a job that is overlapping. So if there are two jobs that are overlapping, A or B, I have a choice whether to pick the job A and move forward, or whether to pick the job B and move forward. So what happens in this case is, when I'm picking the job B, I'm basically skipping the job A, and when I'm picking the job A, I'm basically skipping the job B. And it's natural for them to have different start time or different end time. It can also have the same time. So all the cases can be handled with DP approach, which is pick and not pick. I'll I'll just name a function int solve, which will be expecting index. So I'll just name that as I. So over here, let me write the base case. So this is the base case over here. So if I is greater than or equal to n, so this is, since we are recursion, we need to have a base case. So in this case, when it is n at index n, there is no profit at that point, so we have to return 0. So base case is done. So this is the case where I will not pick the job. I will not pick the job. So what happens over here is, I can say that this is not pick, and I can just increase the index to 1. So I'll just say I plus 1. So I've increased the index and we are good. And at the point where we are picking, so over here now the tricky part comes. The core logic of this problem comes over here when we are picking. So we have the profit first, so we get the profit. So when we are picking up a job, it's better to collect the profit of that job, and the profit of the job will be over here. So we have encapsulated that into a certain data structure over here in vectors of vector. So we have the index over here, and the profit is at index 2. So profit is over here. So this is the profit. And now when we are picking it up, I can just add the profit, and then I can pass the index for the next job that I'm willing to pick. Now the next job, how will I pick that question? Because it needs to be non-overlapping in nature. So I'm writing a function for the next non-overlapping job index. I'm just writing this so that you understand the variable. The variable need not be so big in practice, but next non-overlapping index. Alright, I need to basically pass this index over here, and over here I'll just type a function. I'll just declare another function, find next index. Over here what I would be needing is, basically the next index should be, how are we finding the next index? So the end time of the current index should be lesser than or equal to the start time of the first index of the next job, right? So how we are doing it, the start index of the next job should be greater than or equal to the current index ending time. So I will pass that first. So and before that, and the current index in which we are right now in. So, and since we've picked up the next job, and since yeah, so that is there. Yeah, so that is over there. Find next index. So end time I'll pass first. So jobs, and we are at index I, and the end time is in first index. So I'm passing that, and I can do a linear search over here. I can do that linear search. It's basically int find next index. Find next index over here, and find next index. I'm expecting the end time over here, end time, right? And also what I can do is, so for int I equal to 0, I less than n, I plus plus I plus plus, and over here what we've got to do is, basically we have to just write a condition that if the yeah, so we also need to have the current time, right? So I will pass the index over here. Index also is required, so I'll just write as the first part the current index. So that is I over here, and this is the current index. Int is the current index. Yep, right, that's the current index. So now I have to use jobs. If jobs current index start time, which is at the first element, so it is at 0 index, which is if suppose that is greater than or equal no, so current index is over here, but I would not be needing that actually. I will be needing that afterwards, but right now I'll just show you if why this approach should not be taken. So if jobs I is greater than, or at the start time, we're just finding any start time which is greater than the end time over here. We can just return an answer. I'll just declare that variable, and suppose if we are not able to find any next index, let's declare that as n, because n's base condition is handled over here at line number 24. So we can say that as n. So suppose if you are able to find a start time which is greater than or equal to the end timer, so we'll just say that is the answer. So jobs, so that index is the answer, and we'll break it off because we need not go any further, because we want to find the immediate next job. We don't want to find a job that is suitable, but the immediate next job that is suitable, and that is the answer over here. So this should also work. I don't require the index for now, we'll optimize it later. And I think we are good. Are we good? Will this work? So this will work. Let's see for some cases, and I'll tell you what cases we are missing. So we've got a compilation error. Okay, so I need to add another bracket here. Okay, it should be jobs, not job. And am I calling that function solve? Yeah, I'm not calling that function as well. So solve, and since we're starting with the 0th index, I'll just return that. Add 0 as the first parameter, and yeah. So this will expect it find next index I1. Let us t2 few arguments to function call. Okay, I needed to remove this as well. I'll show this part later on. Yep. Okay, and this over here, I need to return the maximum value. Return the maximum value between the prof pick and not pick. Okay, so this has worked, right? But will this work for all cases? This will not work for all cases. It might give segmentation error as well. So see over here, we've got address sanitizer, deadly signal. So basically we are trying to access values that are not there, or maybe the stack has become too big. So the reason because of that is right now basically we can also access the same index, right? So the current ending time, so we can also go with the same index. Since it is traversing through the entire loop, we can find the same index for the same end time. So we can basically use the same start time for the end time, which is met for the end time, right? We can't do that. So we need a element that at least secludes the current elements, so it can basically give the start time of the same job of which we are passing the end time of. So for that we need to sort this particular data structure, jobs dot begin and jobs dot end. So we have sorted that. So that is also one reason why we had to encapsulate this. So we have sorted that, and we have done that on the basis of the beginning time. So we can sort it with the end time as well, but then we'll need to use a comparator. But since start time is the first parameter over here, so we can just use the default comparator which the STL sort provides. So this is on the basis of start time, right? And over here, then we can pass the current index over here I, and then we can use the current index over here, current index, right? This is the current index that we're receiving, and then we can do the linear search from the next element that is there with the next job, current index plus 1, right? So we've used, given the parameter, added this parameter here, and we've sorted it out. Now let's check it. So now this will not give this address sanitizer error, so we will not be trying to access, or we'll just not have this error. We will do it, but will give us the time limit exception error, because this particular program is in 2 power n 1. So if you see, this time limit is exceeded and job scheduling and the solve function over here, right here, is basically the solve function is 2 power n, and the linear search is in n, and since the linear search is within the recursive function, it is n power 2 and function, so n to n is the time complexity, which is too much. So what we can do over here is, since we have sorted it over here, we can use binary search to make this n as log n. So right now it is n to n, the complexity, so at least we can use we can make it log n to n, right, by just making this as binary search instead of linear search, right? So what we can do over here is, so over here so binary search, what is the low? So the low is current index plus 1, because that is the minimum job that we can take, and the high is the maximum one, so that will be the size of the whole job's error. We can say it as n minus 1, and then we'll just declare another answer, right? Answer, and that we can just default it as n, because n we have handled the base case. So now while low is less than or equal to high, right, and then we need to calculate the mid, which is basically low plus high minus low divided by 2. So this will give us the middle element. Since it's sorted, we'll get the middle element, and then we can see and basically we can see if the mid element, jobs mid, we are basically comparing the start time, right, from the end time. So basically we are trying to find a job that has the greater start time from the end time of the previous job, is greater than the end time over here, right? We can basically just declare that as the answer is mid, that index over here, and we can just say that high is mid minus 1, because since the start time over here is greater than the end time, that means it's present in the first half, and to even narrow it down, we'll divide the first half into even more halves, and that is why we are getting the log n complexity, right? And suppose if that is not the case, we'll go with the second half and say that low is mid plus 1, and over here we will return the answer, or it's better to say as the index, right? That is more better suited, index, and we are basically getting the same thing over here. And let's try to run it. Hopefully no issue comes. Okay, looks like okay, mid minus 1 semicolon. So now at least index also requires a semicolon over here. Okay, so yeah, so this has passed. So at least now we have reduced this complexity from n to n to log n to n, right? So of course even that is too much, so now we need to basically look for the big fish. Even this will give time limit exceeded error. Right, so now we have to look for the big fish. So let's memoize the solution, and memoization is very easy. All we need to do is just just declare a variable vector of int and just say that's the dp and give, you know, have that as the size array and give it a default value of -1. All we need to do is pass that dp over here. It's very easy to memoize it, you know. So this is the main logic, and now just reducing the time complexity is the easy thing. And now on the base case, we can say if dp of I is suppose not equal to -1, all we need to do is return the value, because that is already calculated and that is where we are saving the time. And suppose if it is not, then dp of I is basically the max of that thing, and return over here. The main thing is pass that in by reference over here, because if you're not passing that by reference, so you're basically having the stack values of that, you know, the same amount would be used. So there's no point of using dp over here. So if you're not using this and over here, there is no point of using dp, because it will create that many files and that many recursion calls which will be used, so nothing would be stored. I think we are good. And now let's try to run it. Okay, so of course with recursive calls we need to add dp over here. So dp over here and over here as well, dp, and then let's run it. All good, hopefully. No runtime reference is, I'm getting a runtime reference. Okay, so running this is giving a runtime error. So the reason is, I just realized, so I have declared the value n over here before the n has been populated. So all we need to do over here is basically give it over here, and when we run this it should be all good. And when we pass this, so time limit exceeded exception also should be gone. So that is it. So now the complexity would be log n from the binary search, and n the whole job sharing part, so it's n log n, which is the expected one. And now the space complexity also can be reduced with the help of tabulation, and that I'm leaving you to do. Thank you.